Jai Hind. So today we are going to talk about the next topic of our subject, cryptography and network security. The topic is Chinese remainder theorem. So first of all, we will talk about the actual definition of what this Chinese remainder theorem says. It says that it is a theorem which gives a unique solution to simultaneous linear congruence with coprime moduli in its basic form. The Chinese remainder theorem will determine a number p that, when divided by some given divisors, leaves the given remainders. So whenever we are having certain modules and their coprimes, we will find out the value of certain numbers, and by dividing the moduli part and this number, it will give the equivalent remainder as given by the equation. So we will talk about this Chinese remainder theorem with the help of numerical. So let's take the numerical, then you will come to know how this CRT gives a proper solution to modules. So our question will be x congruent 1 mod 5, x congruent to 1 mod 7, and x congruent to 3 mod 11. This is the actual question which we are going to solve over here. Before that, I want to explain you certain steps which we will follow when we are going to perform this CRT on these given equations. For the step 1, we will find out what are the values of A's and what are the value of small m in this. For this perspective, A1, A2 and A3 will be there. The respectives small m1, small m2, small m3 will be there. So for the value of A, we are having 1, 1 and 3, and m1, m2, m3 will be 5, 7 and 11 respectively. In step 1, we have to calculate the value of capital M, which is equivalent to m1 into m2 into m3, so on till mn. In this particular question, we are having 3 equations, but maybe the value of equation may vary. So accordingly, we are going to calculate the value of capital M by multiplying the values of all the given small m. Here we are having 3 m's. So it means we will calculate capital M by multiplying small m1, small m2 and small m3. Next step says that we will find out the value of respective m's, that is capital M1. We will find it by dividing the capital M by M1. In the same way, if we are talking about M2, we will get it by capital M divided by M2. And if we are talking about M3, we will get it from M3. Always remember this thing. For only this question, we are having 3 equations. It may vary, the number of equations may vary, and accordingly, the number of capital M and small m will also vary. Step 3. Step 3 says that you need to check for each capital M a respective value of x, which is congruent to 1 mod m1. In somewhat like this. Similar way, for m2 it will be x2 congruent 1 mod m2, and for m3 x3 it will be congruent to 1 mod m3. like this. In step 4, we will find out the value of m1 into x1 into small m1 . This is your step 4 now, in which we will take the values of a1 plus m2 x2 a2 plus m3 x3 and a3, and finally we are modding it with capital M. Whatever value will be calculated out after this step, that particular answer, that particular value of x, you can say we are calculating the value of x over here, that value of x we are going to put in our actual question. After solving this, it will give the respective remainders, and we can cross check whether our solution will be correct or not. Means whenever we will put the value of x over here, after taking mod with 5, it will give 1. The value of x with mod 7 will give 1, and the value of x with mod 11 will give 3. So by that, we will come to know our solution is exactly correct. So let's move to our actual solution part. We will follow all these 4 steps to solve this Chinese remainder theorem. So we will take the same question as it is, that is the value of x is equals to, congruent to 1 mod 5, x is congruent to 1 mod 7, and x is congruent to 3 mod 11. So here we have a1, a2 and a3 as 1, 1, 3. Value of m1, m2, m3 as 5, 7 and 11. So let's start with our step number 1. We will find out the value of capital M by multiplying all the respective values of m1 dot m2 dot m3. So here we have 5 into 7 into 11. So we will get the value as 387. So by multiplying 5, 7 and 11, we will get the value 385. In step 2, we will find out the value of capital M1, capital M2, capital M3. Here we have M by M1, M by M2, M by M3, like this. That is 385 by M1, that is 5. It will give you the value as 77. Then 385 by 7, it will give you the value 55. And 385 by 11, it will give you the value as 35. All right. Now in step 3, we will find out the values of the values of m1 x1 is congruent to 1 mod m1. So from the previous slide, we can take the value of m1 as 77 dot x1 mod small m1. Here small m1 is 5 is equals to 1. Now we will take this mod. 77 mod 5 will give you 2. All right. Now we will find out this value of small x1 in such a way that when we will multiply 2 with that value of x1, after taking the mod by 5, it will be equal to 1. So if we will multiply this 2 by 3, 2 3s are 6. When we will take 6 mod 5, then it will give 1. So we can say the value of x1 is equals to 3 over here. I am repeating this step once again, that we need to take the value of x1 in such a way that when we will multiply this x1 to this 2, after multiplying these, whatever value will be generated, taking mod with 5, it will give you 1. So we know that 2 3s are 6 and 6 mod 5 will give you the value 1. So the x1 is equals to 3 over here. For next value, m2 x2 is congruent to 1 mod m2. The value of this capital M2 will be 55 x2 mod 7 is equals to 1. Now when we will take 55 mod 7, it will give you, so if we will take 7 7s are 49, then it will give you the remainder as 6. So we will write the remainder over here as 6. So we will find out the value of x2 in such a way that when we will multiply this 6 with the x2 by taking mod with 7, it will give you 1. So obviously, if we will take the value of x2, that is 6. 6 6 are 36. When we will take 36 mod 7, it will give you 1. So obviously, the value of x2 is equals to 6 over here. Now we will find out the value of m3 x3 is equivalent to 1 mod, the congruent to 1 mod m3. m3 will be the 35 dot x3 mod m3 will be 11 and it is equal to 1. Now after taking mod 11, 35 mod 11, it will give you the value as 2. You need to find out the value of x3 in such a way that when we will multiply it by 2, taking mod by 11, it will give you 1. So we will make it as 12. To make it 12, we need to divide it by 6. So the value of x3 will be 6. 6 to the 12 and 12 mod 11 will give you value 1. So like this, you can see in step 3, we have calculated the values of small x1, x2 and x3. Now in our step 4, we are going to perform, we will find out the value of capital X in such a way that m1 x1 a1 plus m2 x2 a2 plus m3 x3 a3 mod m will give you the final value of x, which we are calculating. So I am writing the values of m1 respective values: 77 into 3 into 1 plus 55 into 6 into 1 plus 35 into 6 into 3. Now we will take the mod with capital M. We have calculated the capital M as 385. So here the values after calculations is 231 plus 330 plus 630 mod 385. Here it will give you the value of x as 36 finally. So this is the final answer. We can cross check whether the value of x equals to 36 is correct or not. We have calculated it correctly or not. We can cross check it this. How we can cross check? We will go back to the question. This one is our question. We will put the value of x over here and we will check whether all these three equations are satisfying or not. So we can check that. 36 congruent 1 mod 5, 36 congruent 1 mod 7 and 36 congruent 3 mod 11, like this. Mod 5 for this 36, it will give you 1, yes. 5 7s are 35, it will give you 1. For this 7 5s are 35, it will give you 1. And for this 11, it will give you 3s are 33. All these three. So this is absolutely correct. You can see the values of calculated and the actual values available in the question are same. So we have calculated the value of x equals to 36 correctly. Let's take another question, another example to make your doubts more clear. Next question will be x congruent 2 mod 3, x congruent 3 mod 5 and x congruent 2 mod 7. So this is our new question. In this, the value of A1, A2 and A3 are 232. Values of M1, M2, M3 are 357. Step 1. We will calculate the value of capital M by multiplying all the values of a small m. Here we have three equations, so we have three values of a small m, M1, M2 and M3. Like this. And this M1, M2 and M3 will give you the values as 3 into 5 into 7. So the value of capital M will be 105. So this is the value of capital M. Now in step 2, we will check M1 equals to M by M1, M2 equals to M by M2, M3 equals to M by M3. So capital M is 105 divided by 3, 105 divided by 5, 105 divided by 7. It will give you the respective values as for capital M1 it is 35, for M2 it is 21, and for M3 it is 15. Now let's come to our next step, step 3, in which we are going to find out the value of M1 X1, in which it will show you the congruence with M mod small m1. So here the value of M1 will be 35. We will find out X1 in such a way that after performing mod 3 it will give 1. Like this. So when we will divide it by 3, 3 ones are 3, and it will give you 3 ones are 3 as remainder 2. Like this. Now we need to find out such a value. When we will multiply it by 2 and take mod with 3, it will give you the value as 1. So we can take the value of X1 as 2. 2 to the 4. 4 mod 3 will give you value 1. Now next value. Here we have the values as 21, mod M2, that is 5, equals to 1. So to which particular value we will divide it, when we will divide it, it will give you value 1. So by which value we are going to multiply it? So it will give you the value as 1 mod 5 equals to 1. Six. In the same way, you can check it over here for M3. Sorry, it's X2. X1 we have calculated here, it is X2. So X3 congruent to 1 mod M3. We will write down the value over here, 15. So when we will divide 15 by 7, it will give you 1. 7 2s are 14, it will give you 1. Like this. And we can take the value of X3 as 8, because 3 mod 7 will give you 1. So these are the three values of X1, X2, X3, 2, 6 and 8 respectively. The value as X is equals to M1 X1 A1 plus M2 X2 A2 plus M3 X3 A3 and mod capital M. So the values are 35 into 2 into 2 plus 21 into 6 into 3 plus 15 into 8 into 2 mod 105. So now the values are 140 plus 378. After calculations, you can easily find out all these values, mod 105. And finally, the value of X is 23. Now again we can cross check whether the value of this calculated x is equals to 23 is correct or not. We will put this value of x in our three equations given in our question. This is our question. We will put the value of x is equals to 23 over here. If it will give you the respective values of remainders, it means our solution is correct. 23 mod 3, 23 mod 5 and 23 mod 7. You can see now it will give you the value as 2, the value as 3 and the value as 2, and you can check these values are exactly same as our question. 2, 3, 2, 2, 3 and 2. So by this we can see that by using our Chinese remainder theorem, how we have calculated the value of x. So we have talked about Chinese remainder theorem, question 1 to calculate the values, question 2 to calculate the values. That's all.